Okay, I think it will record. Just check it and let me know if I am missing recording. So let's go ahead now. Uh, because we just had some expo in our office, like on different things. Even people from Broadridge and Uber, they came to our office, and we had this a big what we say webinar kind of this thing. So and they came up with all innovation happening across the world and in their companies. So and one such thing is one guy implemented a chatbot with this Rasa thing, which is most happening now. So maybe we'll see. We'll also do something on that. So finally, yesterday we had a discussion about Lambda. So unfortunately, what happened is by the time we are about to end the session, we had a network glitch actually. So I got disconnected suddenly, but it's okay. We almost had discussed the Lambda topic. Only thing is I'm just trying to show you how to get that performance difference. That should be fine. We can discuss those scenarios again and again. This is not the last time, or this won't be the first time for us. Okay, we keep checking on these things again. So that's it, friends. That's about Lambda. We had a quick and a clear discussion in the yesterday's session because we dedicated a whole session for Lambda topic. Next one, inner functions. What is an inner function? It is a very simple topic. Inner function is very simple. It is a function within a function. Sometimes in programming, we might use inner functions, function within a function, which is nothing but what we call inner functions. And we generally sometimes create inner functions, depends on our need and necessity. Okay. And here it's very simple. Generally, we can create a we can call external function. That external function will implicitly call internal function. That's how the design is. Okay. But on high level, if you just want to get a quick idea, what is an inner function means, simply speaking, a function within another function. That's all, friends. So that's all. Next one. This is the, let's jump to the example directly. Instead of wasting time on more theory, let's do backtracking. Let's start example and try to get the topic from the example itself. Okay. So new Python, shall we say? Array. Enclose this. We can clear this. And then now it looks, now the PyCharm looks more interesting, right? So what is the topic now? Inner functions. If you can see TA. Okay. We'll just understand the concept clearly, and then what do? We try to do some small project on this and then jump to the next topic. So inner function means, simply just now we got a quick idea, a function within another function. Sometimes we might use this to do a better modularization inside this coding. Okay, next one. This is the simple example of inner function, something like def f1 and then def f2. So define function 2 again. Now you see we created another function inside f1. And this is nothing but, so you can simply say, I'm just creating a very simple function just to get the topic quickly. So you can say, hi, I am inner. Okay, you just creating a very simple scenario. Now, what do? Now you have to call your outer function. When you call outer function, then your outer function is called. Again, if this should be called, this should even we should declare a call for inner function. So how do you declare it? Simply here you can say f2 instead. I think I was trying to create f2. So just call it implicitly inside the function. That's all, friends. You see, anyhow how to create a function out of normal functions. We just created an inner function inside function, and that inner function you can implicitly call from where? Within the function itself. Now what happens if I call f1? that F1 is going to call F2. That, that's all, friends. Sorry. That's all. This is the simple idea. So this is outer function as per this thing. So this is outer and this is inner. Okay. And we can create certain, even we can use this inner and outer functions to segregate our logic, inner functions. Okay. Now, maybe this, I don't think we have any indentation with comments. Okay. Even comment is fine. Now we should be fine here. Let's start. That's all, friends. This is the concept of inner functions. Maybe if you want to apply it for some scenario, you can take some any generalized scenario and you can apply. Like if you are finding some shapes, you can create your outer function as shapes, and inside that you can create some logic for triangle, rectangle, square, all that. So for each one, you can create one inner function. That makes more sense. Okay, you got it right. But anyhow, this is the idea. Understood, right? Maybe if you want to trace it, you put a debugger as well. Now I'll run in two things. We'll do a normal run and then we just quickly do a debug run. Okay, we'll do two runs. So you get a clear idea about the flow as well. Okay, let me run this program now. Just run this. This is finally, maybe if you want to call outer as well, then you can do that as well. So if you want to use outer function, where shall I place my statements? I can keep my statements either here, anywhere not inside inner function. That whole space belongs to outer. And once you come here and all this something inside this inner function belongs to inner. Got it right? Now you can put your statements anywhere in inner function. Oh, sorry, in outer function. So I put it as outer. Now you run this again. Just do a normal run. Don't do go for debug. Now you can see outer. I am inner. Now, if you want to see the execution flow, how this outer is called and how outer is calling inner. And if you want to see that, just run the put a debugger at this function call, outer function call, right click, and then debug inner function. Okay. Now it just starts executing program in debug mode. You can see here we are here. Then just say step over. Sorry, but this I should not say step over. I should say step in. If you are debugging a program and if you want to get into a function through function call, then here you have to choose what is that step into. If something is a function call and you are debugging it, and if you want to get into that function, choose this step into. Step 4 means line by line execution. So apply this. So now you can see a clear jump of control into the outer function. Now just go line by line. Now you came to the, see, from there it jumped to the outer. Why? Implicitly, this is being called. Now again, you can say step over. Okay, sorry. Still it is in the process of coming to this call. This call didn't get executed. Okay, fine. Now step into. Again, you can see the jump got it into the inner function. Now again, step over. Now after executing inner function, it just again control came back to the inner call. Again, step over. Again, this whole function got executed. Finally, the control is written back to the caller otherwise. So this is the execution flow, friends. So first the control goes into the outer. From outer, it goes to the inner call. And from inner call, it goes to the inner function. All that code inside inner function is executed. Finally, it comes out of that code block. Okay. Once the execution is completed, the control completely written back to the actual main color, outer color. Okay. So that's all, friends. This is the quick idea about what is that inner functions. All of you are clear on that. So that's all. Maybe if you want, you can quickly tell this simple program. I'm just sharing this with you. Let me share this. Not here, here, here. Is this clear for everyone? Everybody is clear on this? Understood what is inner and how to call it? Fine, right? Next, after this, the next topic is we are done with inner. That is enough for us. Just get some idea. Maybe if at all, if any scenario is there, then I'll just try to add that scenario for you in our future projects or programs. Okay, when you are doing some scenarios in future. But for now, let us just get some idea about inner. That is enough because we don't use that much of inner functions while doing development. At least I didn't use much of that. Okay. Maybe if someone has opportunity, they might apply that. Next one, decorators is actually a little simple topic.
Sir,
So
one doubt. Uh,
yeah, is
Krishna, yeah.
yeah, Krishna.
Sir, can we call inner function directly?
Yeah, possible, Krishna. Yeah, we can
Okay.
call inner as inner directly also. So let me just show you calling inner, right? Yeah, we can do
Yeah.
that. But that has to be done in through outer. We cannot directly call it, but through outer function we call inner. Let me just show you that as well. I think let me get the syntax right. How to call inner function, not inner class in Python. Just like outer dot inner, it's using. Maybe let me just see. This is object, okay. We don't, this is okay. This approach will not work. Okay, fine for this one. This should be fine for us. And foo dot, okay. Same thing, friends. Let's just quickly check it. Okay. You can simply say F1 dot F2. This is what they are doing. Let's run this and see. We can remove the debugger. We don't need debugger. If it is F1, we can, okay, we'll do one thing. We'll use two test cases. Test case one, just calling outer function, just F1. If we call F1 implicitly call inner function. Right. Next one, another one is F1 dot F2, and then just run it on this one. Should I say just a minute? Okay, let us try this once. Even this is, I think we are getting output. Outer. For the first time we are getting outer and then inner. Oh, okay, fine. Let me just see, get some. Let's see in this website what this guy has given. These are all okay. These are internal class related one. We don't need this. We just need something. Okay, this is not that great. This is generalized example which we did right. Similar one. This is also what we did right now. Okay. Okay. Same process. I think this guy asked for registration. Let's leave it. Then finally, instead of all this wasting time here, what is that? How to call inner function directly. Sometimes ChatGPT also goes wrong. Yesterday we just came across such a scenario. Okay, you should return it like how you written this one. Yeah, this works. I remember this. Okay, we should return this one. So simply here, what is that we should do is you are calling this inner function, right? From inside outer, right? Simply what you have to do is if you should call it directly, you should say return F2. Means we are returning inner function. Now you remove all this. You don't need this. Okay, come to the here. Simply what is that you should do is inner something like func equal to just say F1. So this F1, right? When it is called, it returns inner function. This inner function as a value. Now I believe you should also apply a call on this returned value, because if inner function should be called, we should make a call on this variable. Let's okay, we'll do one thing. We'll go one by one. So let's run it now. So we got outer now, right? Now what you do is try to run in run this. You see here. So this is the approach, Krishna. Is this clear? See what the only simple
Yeah.
thing is just return that inner function, and just once you return it, once you call this outer out, the return type of outer is a inner function, and just apply a call on that variable, then it will automatically call visual the inner function. Is that clear?
Yes.
Clear, Krishna? Just let me share this also. This is like calling inner function directly. Sure. Directly from driver program. What program? Driver program. Only thing, same like it's like returning value from a function. That's all. If it is value, we just directly print it or use it in the subsequent process. If it is a function, again we should apply this a call on that variable, whatever to whichever variable we are initializing that return object of inner function. This is actually this returns object of inner function. On that object, we should apply this function call. That's all. So sharing this with you, this code as well. Let me share this with you. How about others? All of you are fine. You get this, Adish or Pradeep. All of you are good, right? So that's the idea. Thanks for
Yes,
asking
Mr.
question, Krishna. Next after this, decorators. Decorators something which we use most of the time. We try to use built-in decorators. Maybe when some people are working in some web technologies, like in web development, something like Django, Flask. Maybe in such kind of projects, people use a lot of decorators. But usually when automation like what we are doing, or we have a total Python development team beside me, even they don't use much of all these decorators, because I generally keep seeing their code as well. So decorators might be used mostly with certain web projects. Okay, that's what my understanding is. But anyhow, but sometimes people ask in interviews, what is a decorator? And most of the people have a feeling that this is a little complex concept. But I don't think so. Just let's take a simple example and quickly build this decorator. So decorator means simple, friends. It is also a function. Okay. Only thing is here we have two things. One, the actual function, and a decorator. So what is that? When you are working with decorator or a decorator function, what is it? So generally there are two things here. One is the actual function. The second one is a decorator. So actual logic will be in what? Let me clearly write everything here so that you get that first the basic understanding. So when you are working with decorators, what is the point, friends? You need two things: the actual function and a decorator. Like, let us derive some quick understanding from real life example. So there are two things. Decoration means what? Suppose you, let's take example of ourselves. It's ourselves, and maybe, right. Generally, when you are going out or something, most of us have the. I don't actually. I don't have that habit, but most of us have this. What is that? Actually, we have a face and a body. Yes, right. So while going out, or while going to a function, or while going to some special events, we have a little extra makeup that day. Will you agree or not? That is also called decoration to face. What do we do? If you want to do makeup, first thing you need something. What is that? Your face that should exist. So that is actual function. Means there are two things. One, an actual function. Two, a decorator on top of that. Now, what is this makeup is doing to your face? There are two things even in this case, real life example. You have a face and a makeup. So initially you have actual function and you have some logic with that. Without actually modifying the or touching that original function, you have to make some change to that original function or actual function. So that is what decorator does. You got it right. So I'll just write a point here. Without, this is a very simple thing. Without, so we have actual function and a decorator. Or you can say normal function or parent function and a decorator. Okay. Without actually modifying which one? Actual function. We try to change the we try to change the some, or we try to add something, change the logic of actual function. Okay, I'll just take a very simple example to make you understand. Without actually modifying the actual function. Means what? We don't touch anything in the actual function, but we try to make some change to that. How? We try to change, we try to make some change to that. We try to make, let me add like this, that we make some change to that. I'm just making in very simple terms, okay? Just taking it in a very simple language. Change to that without actually modifying the actual function. And how do you do that? How do you try to make some change to the actual function without touching that function? That is where we need decorator. We try to make some change to that using decorator. Simply speaking, what is a decorator? Decorator is something which will modify something on actual function without actual function doing, without making any change in the actual function. You got it right? Means simply speaking, you don't change actual function. Okay, or the code in actual function, but some change is applied to that. What is that? But some change is applied to that. How? Some change is applied to that. How? By using decorator. The simple solution. How means what? Use decorator. So what decorator does here? Decorator is also a function which makes a change on top of actual function without actually modifying the original function. Okay, what is a decorator now? Simply speaking, I am writing here because it makes more clear for you. Decorator means decorator is a something which makes change on a, it is a function. It is a function. What it does, which makes change to actual function, change to actual or original or parent, you can name as you like, actual function, without directly modifying the actual function. Directly modifying the actual function. For this, just to quickly remember, this scenario. This makes more sense, right? Is this clear for all of you friends? First, understand the definition here. Understand the concept, then let's apply example so that it should be very clear for you. Do you get this concept now? What is a decorator? Right? Best example is a face and a makeup. Face is actual function, but you want to enhance your beauty or handsomeness. So how do you do that? You apply a makeup. That is decorator. Or generally, applying makeup is also a decoration to face. What decoration do? You are not modifying your face, right? You are not doing anything on your face. Only thing is you are adding extra layer to your face with a makeup. That makeup function is nothing but enhancing your beautiness. Same concept is applied here. But the question is your face getting modified here? No, right? You are applying something externally to enhance that beautiness. That is the decoration here. You got it right. But what's happening here without making any change your face, because that makeup will be there for some time. After that, it will be gone. Point is simple, right? Without changing anything to your face, because all of a sudden your our face don't go become too this thing. It won't glow too much or it won't shrink so much too much. So that is the idea here, friends. Just remember that face and makeup example for decorator. It can quickly connect you with the concept. You got it right. So your makeup is like a decorator, your face is like actual function. Just apply makeup for face, which enhances beautiness. You are actually not modifying your face when you are applying makeup. That makeup is doing some change to you. That's all. That is the idea. Now you should get a clear picture about what the decorator and this function. Now, what is that we should do? Just take a simple example for decorator. Let's not make too much of complexity here. Okay. So what do we do? Do you get the concept of decorator? I spend little time here because this is something first we should understand the scenario of that concept. Then example should be fine. Simple decorator example. Okay, I'm taking directly from the this thing itself. Or you can ask our chat babai. Okay, you can ask there as well. It's up to us. Okay. So this is a decorator one. I don't think something looks like even inner function, but we are not interested on inner functions. What we want decorator. Yeah, this should be fine. This see, even here this guy gave that make pretty example. See, so it's more or less little connected with the inner concept as well. But still, this guy didn't apply what is that decorator. So even this is not decorator example. Even this is not a, yeah, here we are applying decorate. This is actual decorator concept. Okay, I'm taking direct example because we already know at least 70 to 80% of technicalities of decorator. We know inner functions, we know outer function, we know about calling functions, everything. Only thing is we should connect all the dots and apply that for decorator. That's all. So what do you do right now? You take this, copy this scenario, go to our Python and create here new Python file decorator. Okay. Just get the idea of that. Later on, if you have any scenarios like that in your project, you can apply. But mostly, you don't need much of decorators. With my experience, I am saying it, unless you are working on some web projects. Okay, like web development or UI development, because it needs some Django or Flash, where you might use decorators extensively. Okay, so this is a simple scenario. This is your normal function. See, to understand this concept, you don't need to be too technical. You don't need to have too much of technical knowledge. Simply a basic idea of functions. So this is normal function, right? This is decorator. Two things. Understand this step by step. We have two things. One normal function, one decorator. And when you look at the code, we don't have really something challenging to understand here. All this is very simple code to understand. Now you have an ordinary method here. And then that is just saying I am ordinary. That's all. Now what you are doing now, you when you call ordinary, right? Suppose you don't have a decorator. You don't have. Let me remove this decorator here. Run this. Now we don't have any link between this function and this one. Now if I run this, I just get output as I am ordinary. Now I am adding one more function on top of it. Now these two are like any other two different functions. We don't have any connection between this function and this function. Okay. Now to connect this, we need to apply something called decorator. Decorator is something which we use at the rate symbol and just take this function name and add it on top of this ordinary function. Sorry, add it on top of which one? This original function or actual function. Now what this make pretty do? We are adding a decorator on top of this actual function. Then this make pretty without actually changing this function, this original function or the actual function. It will add something to this ordinary. But you don't do any change in ordinary function. But who helps us? This pretty function helps us to add something extra to ordinary without actually modifying ordinary. You got it right? So now what happens when I apply decorator here? So here this decorator, when we call ordinary, first it will call decorator. Now what decorator is doing? You can see here. Decorator is nothing but your make pretty. This pretty function takes function as input. What it takes? It takes a function as a parameter. So far we have seen function accepting values, primitive and data structures as parameters. But for first time, we are creating a function which takes function as a parameter. Now what this decorator takes? Decorator takes a whole function as a parameter, which is nothing but your original function. Now you are creating an inner function. See here, just updating I got decorated, right? And what is that and here, if you see here, from there you are calling this inner, right? You can see here. What we are doing in inner, we are actually after updating this statement, there we are trying to call this parameter, whatever we are declaring here. And finally, what we are doing, we are totally returning inner. It is more or less having a connect with inner classes. Decorator is something which has a dependency on inner classes. Why? Because this inner is something which is doing actual change to the outer one. And on top of that, we are creating a decorator. Now what inner is doing, just it's printing I got decorated. And what is this function parameter, which is nothing but object of this actual or original function. What function has object of this one, and that is passed to this. Now what you are doing on top of this function, original function, you don't touch this directly, but you are passing this as object to this decorator. Decorator takes this original function as a parameter, and what it does, it adds some extra logic to that. Let it be just a some print or whatever it is, or some logic or whatever it is. This decorator adds something extra to your actual function, and after that you are calling your original function and returning the whole process as one value. You got it right? Whole process as one value. Now what happens? You get two statements when I call ordinary. See, when we call ordinary, we get I am ordinary, I got decorated. But I am ordinary is from the actual function, right? And I got decorator from the inner. So what you are doing here, simply speaking, here we are not doing much here. In this decorator, we are what we are doing here, we are including this outer function call as well. We are merging or we are inserting. What we are doing here in this decorator, we are bringing inner function and outer function together in this decorator. It's more or less what is that we are trying to insert outer into the inner. And what happens now? That will do the actual job. When you call ordinary, it calls a function of itself as well as inner together. In that way, what happens? This something what we are adding here, apart from this, we also get this. You get this, friends? And finally, what you are doing after merging inner with outer or outer with inner, after inserting outer function called inside inner. This is just a function called to outer. For a change, what we are doing, usually we call inner in outer. Usually what we do, inner function in outer function. But for a change in decorator, we call outer in inner function. Just to show that this is getting modified implicitly in the decorator. Are you following, friends, or am I confusing you? Are you getting this? Can I get an S from all of you or no from all of you? I'm trying to make sure you understand this in just simple way. Are you following? Is that clear for you, friends? Just let me see in the chart. That's all. See here, simple, friends.
Yes,
We
sir.
have to, yeah, we have two functions. This outer and inner. This sorry, outer and decorator. Decorator just simply makes change to this outer by taking the outer as a parameter, and it uses an inner function. Just merges that outer with inner. Simply, you can see we insert outer function or outer function object as I called inside inner, so that we merge both of this and return that whole thing as one value. What we do, return the whole thing as one value. So finally, what happens when I call ordinary, it will try to call both. First, it calls what? It try to print this, right? No, sorry. It, yeah. First, it comes here. Pretty. It comes to pretty. Call this function, right? It comes to takes the parameter, and finally, what it will do, implicitly it comes here again, comes to the return. While calling return, it try to call inner. While calling inner, anyhow, we'll debug this instead of me doing this debugging process. We'll go with breakpoint so that that gives more clarity for you. So let me just show you a debugging process here. Let me put a breakpoint here. Let's do the debugging, how it works. Before that, let me run it in normal this thing. Right after this is a decorator, friends. How do I add decorator? Just apply at the rate symbol and add that function name here. Declare that function name or decorator name here. Whatever that we add on top of function, we call it as a decorator. What it does is it is just making some change to the actual function without actually modifying this. And all that change is happening in the decorator function by using some inner function. In the inner function, what you are doing, this is till this we are fine, till this, right? This one is fine, this one is fine. The only addition is we are adding this extra function call. And this is nothing but a function call to outer, right? Maybe if you want to see all that step by step, I'll do a debugging. Now let's run it. Let's do a normal run. Then we go for debugging. Let's run this. See here, you got two things. I got decorator, I am ordinary. And what is happening here, simply speaking, this is like doing a setup inside inner. What is that? We are just doing a setup inside inner. Simply speaking, that's what we are doing is usually we call inner function from outer. For a change, decorator has a function call of outer inside inner. Simple. If you understand this, this is the concept of decorator. We are reversing that what we did sometime back, few minutes back, while we discussed that inner and outer example. So you got this clearly, right? This should be very clear for you. Only thing is we are inserting a call to outer function from inner. Honestly, if you ask, this is not a big this thing, a great setup here. They are just only doing one thing. We are intelligently passing this parameter of outer to this decorator. In that we created inner, and first we are trying to print something in inner, and then we are calling outer function there, and finally you get output like this. I got decorated, I am ordinary. But only thing is what, Suppose if someone don't sees this or don't get this, if you they only see this ordinary. And when you call ordinary, it is not only getting I am ordinary, but it is also getting I am decorated. Then this is something like a surprise or a wonder for us. Hey, just calling ordinary, I am seeing right too many things here. If it should print only I am ordinary, but it is giving me I am ordinary, I got decorated. Suppose I want to interchange these statements, then what is that? Just make this outer call function as a first function and inner call function statement as second one. Let us see this now, how this works. Right? Let's run this and see. See, I am ordinary, I got decorated. See, what is this here? Finally, if you remove this, this is inner function topic. What topic? This is the concept of inner function. We have both inner and outer. That's all. Only thing what we added intelligently, we just placed the object of outer function inside inner function. And for that, what we are doing, we are passing the parameter we are passing this function as a parameter to this decorator. That is implicitly passed. You don't see any parameter passing here. When you just put decorator on top of function, automatically that decorator is called, and to that decorator implicitly your interpreter passes the name of this function. Now you are just calling func on that. Right. This parameter name can be anything, friends. It's not like it should be only func. It can be ABC or XYZ also. Don't think that just to get that idea, this is we are passing a function as parameter. We put func here. Otherwise, this parameter name can be anything. And what happens? This ordinary is passed as a parameter to that. Once you pass this name of method or this function object as parameter, call it wherever you want. If you call it before this print, first outer function is called this one, and then inner this statement is printed. Suppose you call it after that, then what happens, sir? First, what happens, sir? See here. First, your inner function print is called, and then outer function is called, and then the print of outer is printed. It's all about where you are placing this parameter here. It's not like you should place in inner function. You can use it anywhere you want. Simply speaking, understand the concept. It's more or less just passing the object of outer to inner and just calling it wherever you want in that decorator. And they named this whole function, this setup as a decorator. That's all. And to call this decorator, they just put some at the rate and this function name. And people are calling wherever you see in any code, just remember it is a decorator. Means it is taking on whichever the function we declare decorator, it takes that function as a parameter or that object as a parameter. That's all. So what do you do with this? If you want to make change on this and you don't want to touch the logic in this function and you want to make some change to this function, then we create a decorator like this. Okay. And then take this as a parameter to this decorator and make some change on this original function and then just return that inner function back. So this is how we create a setup for this process. Is this clear? I think I tried to explain, re-explain again and again. This should be clear now. Finally, got it right. Finally, we can see here all the different sorts of testing we did now. Now let's debug this code. Finally, we can end this topic of decorator. Now you can see we started with decorator and go debug. Now is this a method call? Then say step into. Now finally when I say step into, it didn't go to the ordinary. Why? Because it will internally interpreter will just see if is it just a normal function or is some decorator there declared on top of it. If interpreter sees this decorator, immediately it will jump to the decorator. Finally, what happened? It has gone to the decorator. It passed that. You can see inside function. Put a cursor here. You can see the object of outer function. What is that? When you put cursor here, this is the object of this function. If you have any doubt, let me just show you. You put a cursor on this as well. Not this. Do one thing. Add a print. print statement, and then directly print the function name without applying that parenthesis. Then this prints the function object. If you just print only function name, you get the object. You can see here. This one here, this one here. See, put here cursor. Both will be same. Check that. Check that hexadecimal code in the with parameter, hexadecimal code at the parameter. And also see here, I'm putting cursor here. See the hexadecimal code with at 11 statement with ordinary function name. Both will be 100% same. Simply speaking, you are passing this as a parameter to this argument. Got it right, friends? Finally, what happened? It comes to this. What it will do? It won't directly get into the inner function. That call should happen. That call is happening from the return. First, it comes to the return, and it sees there is a call here, and it try to once this is executed, it will try to get into the inner function, and then you can see now we go by step here. What happened now? It executed print of inner, then it came to the function call of outer. When we execute now, if I say step over or step into, this is a function call, right? Function call to outer function, this one. Now what happens when I say step into? See, observe this carefully. What happened now? The control jumped from here to here. Why? Because this func parameter is holding object of outer. So when you are applying a call to that object, it would definitely go to that function itself. So it has gone to ordinary. Now step over. Again, see, once that is executed, wherever function is call is coming from, it has jumped to that function call. Because calling is happening from here, then automatically control from here, it will jump to that actual function and then execute that and come back to the caller position. Right? See, same thing. We did flip it. We just flipped the process. We call inner from outer. That's how usually we do. For a change, what we are doing, we are calling outer from inner. Simply speaking, nothing more than that. This is the concept. If you just get that, we are done. We don't need to break our head here. Okay, and finally, this execution of function is over, right? And you can see now step over. When you say step over, this return will be done automatically. The whole object of inner function will be written back. Okay, now after that, again step over. You can see you get both printing here, because in first case it will print I got decorated. In the second case, when we call that, it will print I am ordinary. So when we call ordinary, so first it will straight away go to the inner and try to print it, and then again come back to the outer and print that. And finally, when you see the output, you see both in one shot. Got it right? This is the simple idea of decorator concept. I hope it should be clear for you. I try to get more into the detailing here. Do you understand that? Simply speaking, if you ask me, we are just flipping the process. Generally, we call inner function from outer. For a change here, if in a decorator concept, we are calling outer from inner. Just understand that over. And for that, what we are doing, we are passing outer function as a parameter to this decorator. Whichever is on top of that, it will implicitly pass this function as parameter to this. That's all. Over. This is the story, screenplay. You got it right, friends. Done with this. Hope you are good. That's all. Do you get it, or did I believe I definitely made this simple for you. That is my understanding. You have to tell now how simple, how clear is that for you? Are you clear on this? Clear, friends? Let me share this code base with you. So just me add some comments. What are the comments? So here, decorator function. Okay, and this is actual function. Maybe you can name as you like. Okay. Okay, and here this is a call to actual function. FUNCPAON. And here, what is this parameter? This parameter is a put hash and add some comment here. Func is a function, actual function is a parameter which accepts function as parameter. And again, I told you, it's not like it, you should put func there. You can put ABC, XYZ, anything is fine. Just for naming convention, we put it func, that's all. Okay, that's all, friends. This statement should be fine for us. And this is a function called to actual function. So that's all. So save it. I hope we ran this multiple times. Let me share this code base with you. Okay. And then come here, code snippet, and this here, insert. And then send. Good now. I think we are almost done with functions topics. Right. We almost got a detailed coverage on functions. We did almost 3 to 4 sessions. Tomorrow we need to quickly cover up on map function, filter function, and reduce function. And then what is that? We jump to the modules topic. Maybe in between that, we also see integration of GitHub with your PyCharm and how to apply all that GitHub commands. Maybe it will take a couple of days time to get through that whole process, but we do that. So well, before we jump to modules again, we do this all this. This helps you for interviews again, right? How do you do version controlling? What kind of repositories we use, and how you apply Git. Sometimes they ask Git commands as well. And this is just not only useful for Python developers. If you try as a Python, not only exclusive Python, even DevOps people need that. Even data engineers need that. Okay. Or even big data people need that, all this process. So any questions or any doubts? Doubts, friends? Krishna or Bala or Adisha, or Pradeep or Tulsi. Any questions?
No, sir, everything clear.
So did I make it clear for all of you? Right? I hope so. Right.
Yes, sir.
Okay. Okay, then
Thank
we'll stop here. Tomorrow we'll jump to that other topic. What is that? Those things. Then we'll
map.
jump to GitHub topic. Okay, and then again modules, and then we'll take up one more something. I mean advanced topic. One more like that. We'll take one topic, our regular topics, one advanced topic. So that gives you a overall coverage of your Python. That's all, friends. Any more questions? And we are planning actually another session after Pongal holidays. So maybe if you think if you, any of your friends or any of your brothers, sisters who wants to learn this in a proper way, just keep spreading the word to all of their friends. Okay.
Sure, sir.
So that's all. I think did I stop recording? Forget to stop it. Okay.